Hi physics fam, we are going to solve the acceleration due to gravity using the universal law of gravitation. So when we're using the universal law of gravitation, we've got Fg equals big G m1 m2 over r squared. So we know that this is a gravitational force, and we know that we've seen gravitational force before. We know that we've listed it as mass times acceleration due to gravity. So we can set these two equations equal to each other and then solve for the acceleration due to gravity. So we can see that we have a mass on both sides of the equation. This mass is going to reference whatever the extra object is. So we know with gravitational force we're looking at two different objects, one being the Earth and the other being whatever it would be at the altitude of 2 times 10 to the 6th meters. So we can get rid of that mass because it doesn't matter what it is. It's always going to experience the same value of acceleration. So we have little g equals big G mass 2 over r squared. So we already have our variables set up in a way that we can solve for our little g value. Big G is going to be 6.67 times 10 to the negative 11th, and the units for that are newtons times meters squared over kilograms squared. You don't have to memorize this, it's on your formula sheet. And then here we're just going to put the mass and the radius of the Earth. For the mass, we are going to look that up, and we want to put that in kilograms. So that's going to be 5.97 times 10 to the 24th kilograms. And you don't need to include the units. I wasn't doing that before. I don't know why I started now. And then instead of just the radius of the Earth, we need to have the radius plus the additional 2 times 10 to the 6th meters in height. Because again, we're looking at the Earth here. So we need to measure the distance between the center of the Earth and the center of the object. And if we're looking at the radius of the Earth, that only gives us part of the way. We need to also include the distance here up to the altitude. And obviously this is exaggerated, but you can see how we would need to add in the extra distance here. So when we look at the average radius of the Earth, that's going to be 6,371,000 meters. And then we're going to add in the additional 2 times 10 to the 6th meters there. So I've written it out specifically so that you can see exactly what steps I was taking. Then we're going to go ahead and square that quantity. And then we just plug it into the calculator. When you do plug it into the calculator, be careful because you have a lot of exponents and a lot of extra steps. So make sure that you are plugging that in with a lot of parentheses. When you do, you should get an acceleration due to gravity of 5.68 meters per second squared. That is significantly smaller than what we experience on the surface of the Earth because we are further up above the surface here.